I gave you my heart.
Hello guys, so ito na yung ating lesson 1.3 sa ating combinatorial analysis ng subject na probability. So again, welcome back ulit sa ating YouTube channel. So hoping na huwag nyo skip ulit yung mga ads. So sorry kung sinasabi ko to sa inyo kasi talagang gusto ko rin makatulong or konting tulong din talaga para sa channel. Okay, so continuation lang to ng ating combinatorial analysis. So this is lesson 1.3. So in this video, pag-uusapan natin ay permutations lang. So yung mga terminologies, yung mga technique o yung mga examples, tapos mga pro formula na gagamit natin using permutations. Okay, so 1.3 is all about permutations. Then 1.3.1 or yung unang topic para sa permutations na to is yung factorial. So before natin pag-usapan si permutation, what is factorial? Kung sabi na let n be a positive integers, then the product of the first n positive integers is called n factorial, and it's denoted by the symbol, that is n factorial. Thus, n factorial is equal to n times n minus 1 times n minus 2 times times 3 times 2 times 1. So meaning decreasing lang yung number by an integer, so by 1. So for example, we have 6 factorial, that is only 6 times 5 times 4 times 3 times 2 times 1. So hanggang dulo lang ng 1. And we have a defined term here, defined parang relation here. This is 0 factorial is equal to 1 and 1 factorial is equal to 1. So kung tatanungin mo ko, sir, bakit po ba 0 factorial? May nag-prove sa akin dati niya nung ako yung nagtatanong pa dyan, pero nakalimutan ko na kasi paano yung proving, to be honest. Pero once malaman ko, share ko rin minsan sa inyo sa room or sa Google Classroom or sa mga iba pa previous discussion natin. Bakit nga ba 0 factorial is equal to 1? So again, example, pag-usapan natin ito yung example niya. Okay, so example, so number 1, we have 8 factorial. So by definition of factorial, this is just simply equal to, so by definition of factorial, this is just equal sa 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is simply equal to, so gagawin mo multiply mo lang syempre, pero syempre sa calculator may input na factorial so hanapin ko lang din sa calculator kasi pagkakaalala ko may input na factorial, nahanap ko lang din kung saan nakalagay. Medyo nakalimutan ko kasi nakakalito minsan pag di ka gumagamit ng calculator. Neto 3 weeks or 5 weeks na rin yata ako di nagka-calcu. Talagang medyo so multiply lang natin na 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that is 40,320. So this is just equal sa 40,320. Is 40,320. Okay, so no need to write ways or something. Next is, yung factorial na to is pwede natin gamitin sa ating permutation. So, bakit? Meron kasi tinatawag dito na linear order. So, for example, may 10 tao, gusto mo malaman yung different order. Kunyari, may 10 tao, gusto kong hanapin yung different types of order nila o yung ranking. Okay, so kunyari sino yung matangkad, sino yung maliit. Kunyari gusto yung parang random lang. Kunyari ito yung una, si student 1 yung una, student 3 yung una. Yung mga ganong ranking lang. So that is linear ordering. So kunyari linear lang yung pag-uusapan, factorial lang yung gagamitin natin. So tulad nga nito, how many different batting orders are possible for a baseball team consisting of 9 players. So how many different? So kung may 9 na player, so it's either una si second o una si pangalawang player, tapos sunod si pang-apat, or una si pangalawang player, sunod sa kanan si una, o yung unang player sunod sa kanan yung pang-9 na player. Ganun yung gagawin natin dito. Okay, so ito ay parang unang application din ng ating permutations. So, ibig sabihin yung way nito para magawa is kung meron kang 9 player, that is only 9 factorial. Okay, and 9 factorial is just equal sa kung na-observe nyo, this is 9 times 8 factorial. Sir, ba't ginawa mong ganyan? Meron na kasi tayo sagot sa 8 factorial. So, kung may natatandaan ka sagot, okay lang naman. Okay, or ginawa ko lang kasi yan para magawa. Or ganito, this is 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and that is equal sa paano ba yan? So that is 40 1,320 times 9, that is 362,000. So that is 362,880 ways. So sinasabi kasi different battling order. So ito yung number of ways para ma-arrange natin sila. So imagine mo kung gaano karaming arrangement yung pwede mong gawin. So in reality talagang hindi mo magagawa yan. So kaya nga usually in random order So pag sinabi nga meron kang different battling orders tapos in random order naman, so napakaliit din talaga minsan ng possibility na makuha mo yan Okay, so to be honest. Okay, next is the lesson 1.3.2. So we have the permutation. So ito yung definition ng permutations natin. So sabi, every arrangement in order of a set of things is called a permutation. So again, every arrangement in order of a set of things is called a permutation. So katulad nga nung sinabi ko kanina, kung may siyam na player, ano yung different order kung sino yung mauuna, different placement nila, kung sino yung kunyari student 1, 2, 3, 4, 5, 6, 7, 8, 9, kung sino yung mauuna sa kanila. So yun yung arrangement o yung possible permutation. So for example, as illustration na lang, so the set of the letters A, B, and C, so ito ay may different types, may different permutation na. So pwede kasi mangyari, una dito is ABC. Siyempre unang permutation natin is ABC, sunod is ACB, tama? Ano pa ba? Sunod is BAC, sunod is BCA, then sunod is CAB, then sunod is CBA. Okay, so wala naman siguro pwede ng arrangement. So okay, so all in all there are 6 permutations. Okay, so may 6 permutations yung set of letters na ABC. So in general that is 3 factorial. Kung papansin mo, that is 3 factorial, which is equals sa 3 times 2 times 1, which is equals sa 6. Okay, so tama naman 6 yung nagawa natin. So kung gusto mo nga gawin yung tulad nito, so ngayon na rin siyam na player, kung gusto mo i-arrange or isulat, so i-list, yun ang karaming gagawin mo. Imagine mo 362,880 outcomes or possible outcomes yung isusulat mo na napakahirap. Okay, so kaya nga ito yung tulong ni factorial sa kanil permutation. So again, kailan mo gagamitin yung formula na factorial? Gagamitin mo yung formula na n factorial whenever ang i-arrange mo is yung mismong group, yung mismong buong group. So for example, how many different arrangement yung pwede kong i-arrange sa section nyo consisting of 30 student, so that is 30 factorial. Pero pag ito na yung magbabago, so for example, how many different factorial, so for example, meron may 10 estudyante pero 3 lang yung i-arrange ko, how many different arrangement sila doon sa 10? So kunyari, out of 10 student, how many 3 different arrangements? So 3 group. So kung may ginroup akong 3, how many arrangement meron sila dun sa, so how many group of 3 arrangement yung meron sa 10 na yun? Okay, so ito nga yung sinasabi ko. So the total number of permutations of R objects that can be formed from N object is denoted by NPR. Okay, so that's NPR, or the formula is NPR is equal to N factorial over N minus R factorial. So again, meron ditong R objects tapos dun sa N objects. Kumbaga, N yung malaki, then yung R yung maliit. So, for example, 10 tao, 3 estudyante. Okay, so, how many different permutation yung 3 estudyante out of 10 student? So, ganun yung mga ibig sabihin nito permutation na yan. So, again, yan yung formula. So, in simplest way, so for example, gawa na lang tayo dito. For example, evaluate natin si 9 or si 6P2. Okay, so sa 6P2 is just equal sa 6 factorial using yung formula over 6 minus 2 factorial. So again, unahin mo yung grouping symbol. This is 6 factorial over 4 factorial. Okay, so inconvenience, parang pwede mong gawin ganito. This is just 6 times 5 times 4 factorial all over 4 factorial. So in this case, pwede mong cancelin yan. And that is simply 6 times 5, that is 30. Okay, so that is the answer. Okay, so pwedeng ganyan yung gawin mo para lang may makancel ka. So in calculator, kung nakita mo yung NPR na yan, that is NPR, NCR. So gusto ko sulat yung 6P2. So sulat ko yung 6 shift P2. Okay, so dapat that is 30. Okay, so that is 30. Okay, kung makita mo naman yung C na yun, that is combination. Okay, so makita mo yan, meron sa calculator, kahit 2-liner meron yan. So, kung ayaw mo gamitin yung formula, pwede mo gamitin yung calculator. So, wala naman ako magagawa kasi kakalculate mo yan. So, pag sinabi kong gamitin yung formula, gamitin mo. Okay, so again, ito anong difference ng formula na to doon sa nauna? Ang formula na n factorial gagamitin mo pag yung as a whole o yung buong group o yung whole thing is i-arrange mo. Gagamitin mo yung NPR whenever na yung group, kunyari may specific number of group lang or object, yung kukunin mo yung permutation out of n objects. Ganun yung gagawin natin. Okay, ngayon, gawin natin to. So, examples. So, number 1, how many 4-letter permutations can be formed from the letters in the word heptagon? So, ayun nga, 4-letter permutation. So, meaning, 4 na letra out of the word heptagon. So, kung napansin mo ano yung heptagon, wala namang naulit dyan na letter. Tama? So, that is Heptagon. So, wala naman naulit na letter. So, ilan yung letter natin dito? That is 1, 2, 3, 4, 5, 6, 8. So, I think 8. So, sabi, how many 4-letter permutation yung gagawin natin? So, this is just 8. This is just 8p4. So, 8p4 is just 8 factorial over 8 minus 4 factorial. Or simply, kita mo na dito, this is 4 factorial. So, this is 8 times 7 times 5 times 4 factorial. Or all over 4 factorial. Sorry, may 6 pa dito. Times 6. Okay, so muntik na mawala. So that is 8. 8 times 7 times 5 times 6. Okay, that is 1680. So kasi cancel to. So cancel, so therefore that is 1680 ways. Or permutation. Yun yung pwede natin gamitin. Ganun karaming permutation out of 4 letters dun sa heptagon. Sa word na heptagon. Okay, so next is number 2. A class in probability theory. So again, a class in probability theory. So suppose itong class na to. So consists of 6 men and 4 women. So an examination is given and the students are ranked according to their performance. Assume that no 2 students obtain the same score. Okay, so huwag niyang pilosopohin yung sinabing assume that no 2 students obtain the same score. So, ibig sabihin, kung merong dalawa na hindi dapat magkapares na score, obviously, lahat hindi dapat magkapares na score. Baka kasi pilosopohin, dapat 3. Hindi, ibig sabihin sa pwedeng 3. Kung natanggalin ko isa o takpan ko, hindi ko consider isa. May dalawa pa rin doon, actually. Okay, so, dapat assume na yan. Ibig sabihin na yan, pag sinabing no 2 students obtain the same score, lahat ng estudyante yung magkakaiba ng score. Okay, so for example, nag-quiz kayo sa akin. So, may 6 na lalaki, 4 na babae akong pinag-exam sa inyo. So, ngayon nga, i-arrange natin yung kanilang score. So, ito yung una. So, how many different rankings are possible? So, meron daw 6 na lalaki at 4 na babae. So, in all, ang total is 10. Okay, so we have 10 consisting of 6 men and 4 women. Okay, so for letter A, ano sabi ng letter A natin? Okay, so ang sabi ng letter A natin, how many different rankings are possible? So, hindi ko kino-consider yung gender. Okay, so again, hindi ko kino-consider babae, lalaki ba yan? Hindi ko kino-consider yun based sa tanong sa letter A. So, meaning, since hindi ko i-consider, i-consider ko lang yung number ng total number of student na nag-exam. So, all in all, meron 10 estudyante na nag-exam ako. So, therefore, this is 10 factorial. So, meaning, yung arrangement lang nila, so this is just 10 factorial. Or just, this is just equal sa, hindi na ako magkakalcu, partida, this is just 3,628,800 ways or outcome. So, sir, ba't di mo nag-calcu? Hindi sa kabisado ko kasi ang ginawa ko na lang is yung 9 factorial minultiply ko sa 10. Galing ko, di ba? Okay, so for letter B. Okay, next. If the men are ranked just among themselves and the women just among themselves, how many different ranking are possible? Okay, so ito ngayon yung medyo kakaiba, no? Kung yung mismong mga lalaki lang yung irarank ko, tas kung yung mismo mga babae lang irarank ko, ilan yung possible nun? So, ibig sabihin, 2 po sagot. No, isa pa rin. Okay, mag-iiba lang medyo yung sagot. Sir, bakit? Kasi ganito yung mangyayari. Sa lalaki, kung yung mismong mga lalaki lang i-arrange natin, Okay, there are 6 factorial. Sa babae, there are 4 factorial. Tama. Ngayon, ano sabi ng principle ng fundamental principle of counting? Kung merong event na ganito, so yung event na yung men lang yung irarank natin is just event. Tama. Yung event na yung babae lang yung irarank natin is also event. So meaning event 1 and event 2, so that is by FPC, so by fundamental principle of counting. Okay, we have 6 factorial, okay, multiplied by 4 factorial. Ganun yung gagawin nyo dyan. Okay, kasi nga iba ng event yung inirank ko yung mga lalaki mismo, tapos inirank ko yung mga babae. So by FPC, kasi nga hindi naman sila totally mutually exclusive, so kasi pasok lang sila, lahat sila nag-exam eh. Sir, ba't nasabi mo hindi sila mutually exclusive? Kasi nag-exam lang sila pare-parehas. Okay, hindi naman ginawa ng babae nag-physical exam, lahat naman sila nag-written exam, so meaning hindi pa rin sila mutually exclusive. Okay, so we have 6 factorial ay nahanap ko, multiplied by 4 factorial. So ayun, nakita ko yung factorial, ayun, nakikita ko yun, yung may I, ayun, may parang tandang pananong na yun. Okay, so that is 17,280 ways. So this is just equal sa 17,280 outcomes or ways. So again, possible outcomes or way. So pag walang word na way or outcomes, mali yung sagot. So hindi ko alam, kunyari sinagay mo lang 17,280, so minus yun. So may mga deduction akong gagawin dyan. So ito yung mga usual reduction dito sa ating topic na to. Okay, so para masanay ka rin. Okay, next is tuloy ko na. So lipat ko na lang para hindi na ako masyadong mag-cut sa video. Now, for number 3. In how many ways can 8 individuals can be seated in a row of 8 seats if 2 individuals wanted to be seated side by side? Okay. So, ito, imagine niyo yung magiging setup. Sir, meron pong 8 seats at meron pong 8 individual. Ngayon, meron daw 2 individual na ayaw maghiwalay. So, meaning mag-shota yun. Get your idea? So, meaning mag-shota yung 2 yun. So, let me call yung 2 pangalan na yun na si example ko na lang yung siniship ko last time doon sa isang section, si Lori saka si Boreres, o si Sarmiento saka si Boreres. So sample ko na lang, ayaw maghiwalay nung 2. Okay, so parang shout out na rin, shout up na rin sa kanilang 2. Joke lang yung shout up ha. So this is 1, 2, 3, 4, 5, 6, 7, 8. So may 8 seats. Okay, so may 8 individuals na upo. So, sabi nga, andyan si Lori. Okay, andyan si Lori saka si Boreres. Si LB. Okay, so ayaw kasi nila maghiwalay. Again, ayaw maghiwalay nung 2 yan. Ngayon, saan sila pwedeng maupo? Sir, pwede po silang maupo dito, magkatabi sa una. Una si Lori, pangalawa po si Boreres. Or dito sa pangalawa at pangatlo, LB dito or dito, sir. Basta magkatabi sila. Ngayon, papayag ba si Lori saka si Boreres na dito sila? Na rin na dito si LB. So for example, parang andito si L, andito si B. Hindi po. Kasi hindi naman po yung paikot yung upuan. Ang upuan is row. Okay, so hindi po sila papayag kung ganyan po yung setup. Ang gusto po nila lagi silang magkatabi po, sir. Okay, so again, ayun yung gusto nila mangyari. Gusto nila magkatabi sila. Okay, so meaning 2 sila. So meaning parang kinukuha natin yung permutation out of 8, kinukuha natin yung permutation nilang 2. Okay, so ganun yung gustong mangyari. Gusto nila totally magtabi. So again ha, in-arrange ko lang. So ganito mangyari. Hindi siya yung typical na, sir, gagawin po natin is yung arrangement lang po nilang 2 na parang 8P2. Sir, ganun lang po ba yung magiging arrangement? Actually, no. Kasi ganito eh. Gusto nila seated side by side silang 2. Okay, so the setup is, ang gagawin ko, in this case, nilagay ko lang dito. Gusto ko kasi magkatabi ni LB, o ni Lori sa ni Boreres. So, bilugan ko yung count na yan. Okay, so, since gusto nila magkatabi, nagka-count sila as 1. Again, binulugan ko yan para ma-realize mo, or maisip mo, or ma-imagine mo na, yung scenario na to, gusto kasi magkatabi talaga totally ng 2. Since totally magdalawa sila, magkatabi silang dalawa. So dahil side by side, meaning i-count natin sila as isa. So meaning yung arrangement pa rin as a whole. So ang mangyayari, kung tayo 1, 2, 3, 4, 5, 6, 7. So meaning magiging 7 na lang sila, in which linear ordering pa rin siya. So therefore, this is just equal sa 7 factorial. Pero hindi pa yan tapos. Sir, bakit? Ito pa yung pangalawang i-consider. Maaring naisip mo na kanina pa lang. Sir, lagi lang po ba si Lori nauunang umupo bago kay Boreres? Hindi. So meaning, i-consider din natin yung order nung pag-upo nung dalawa. Tama? So it's either mauna si Boreres or pangalawa si Lori. Okay, so meaning that is 2 factorial kasi dalawa sila. So this is just 2 factorial. Okay, so meaning by basic principle of counting, since may nangyari ulit na event out of totality, so totality, may nangyari pang isang event in which yung dalawa naman. So event nilang dalawa na, sila yung magkatabi. Ano yung arrangement na magkatabi tayong dalawa? Okay, so therefore, that is simply 7 factorial times 2 factorial, that is equal sa 10,080. So that is equal sa 10,080 ways or co-permutation or combination na pwede silang maupo. Okay, so ganun yung mangyayari. Ngayon, lagyan natin konting twist. Sir, paano po kung ganito? Naging tatlo yung gustong magkakatabi. Okay, ngayon ginawang naging tatlo. Ano mangyayari? Sir, kung tatlo na dinagdag natin si Lori, si Boreres, tapos si G. So, hindi ka napapangalanan kung sino yung G na yan o paggitnaan natin. Okay, gusto kasi magtabi ng tatlo. Yan, so magra-random yan. Okay, so since ganyan yung gusto nilang setup, ang gagawin lang nila is just magbabago yan. So magka-count silang tatlo as 1, tapos magiging 6 na lang yung bilang. Okay, so this is just, kung 7 kanina, this is just equal sa, so ito ay assuming lang parang follow-up example, this is 6 factorial times considering yung 3 factorial na positioning nila. So therefore, that is equal lang sa, so solve lang natin, that is 6 factorial times 3 factorial. So that is 4,320 ways. So kung ganyan yung magiging setup, 4,320 ways. So ngayon, sir, paano sir kung ang gusto naman lagi nasa gitna po si Lori? So meaning may permutation din yung dalawa sa dulo. Ipipix mo lang na nasa gitna si Lori. So isipin mo na lang paano naman yung gagawing setup. Sir, paano naman pag ganun? Gusto lang po lagi nasa gitna si Lori kasi nga po parang love triangle yung naging dating. Okay, so dito kasi sa 3 factorial na yan, pwede kasi magtabi yung dalawa. O bahala sila mag-away. So, ayun yung mga kino-consider ko dyan. So, ikaw na mag-isip or parang twist na to, what if pinix ko na sa gitna si Lori? Anong gagawin mo? O ano yung possible solution na gagawin mo? Okay, so again, nilalagyan ko na siya ng konting twist para at least ma-imagine mo ano yung mga gagawin natin dito. Okay, next is we have lesson 1.3.3. We have the permutations with things that are alike. So, ano naman ibig sabihin things that are alike? So, for example, ito yung formula. Sabi, the formula is equal to the n factorial over n sub 1 factorial times n sub 2 factorial times that times n sub r factorial. Where yung different permutations of n objects of which n sub 1 are alike, n sub 2 are alike, and n sub r are alike. So, ano ibig sabihin nito? So, ito usually sa mga letter. So, kunyari, arrangement. Kunyari, yung word na Mississippi. So, yung word na Mississippi, kung gusto mong kunin yung kanyang permutations, ang mangyari doon is, yung mga S, magka-count as 1. Tama? Kumbaga, uulit-ulit siya eh. Okay? So, ngayon, dito, gagamitin mo itong permutation whenever ganyan yung given. So, tulad nito, in how many ways can you arrange the letters of the word probability? So again, yung N1 that are like, so meaning kunwari, kung merong word na S, 4 na beses na ulit sa Mississippi, so word na Mississippi, meaning 4 yung S na yun. So count sila as N1 alike. So both count sila dun. Okay, so ganun yung gagawin natin dito. So ngayon dito, try natin sa probability. So isusulat natin yung total number of words. So yung total number of words na is yung N. Ano yung N natin? So yung N natin dito is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Tama ba? 11. 1, 2, 3, 7, 1, 2, 3, 7 plus 4, 11. Okay, may 11 words tayo dito. O 11 letters, sorry. So may 11 letters tayo dyan. So for N1, that is P. So ilan yung P? That is 1. So for P. So for N2, that is R. Okay, so ilan yung R doon? Sir, isa lang po. That is for R. For N3, for N sub 3, that is O. So ilan yung O doon? Sir, isa lang po yung nakikita ko. And for N4, that is B. So ilan yung binigita ko? Isa lang. That is B. So isa lang din. Next is for N5. For N5, that is A. Tama. Yung B, sorry, dalawa, no? Kasi probability. So B is dalawa. So dalawa to. Okay. Then yung A natin. So N5 is A. Isa lang yan. N6. N6 natin is, siyempre, yung B nagamit na natin. So I naman. So I, ilan yung I? Dalawa. Tapos L sunod, no? So for N7, that is L. Yan ay isa lang din. N8. Tama ba? Probability. So dalawa na yung letter B. Probability. Bility. So dalawa yung I. Tas Y. O T isa. So N8 is T. Isang T. Then for N9, that is Y. So that is Y, isa lang. Nagkabaliktad na nilagay sa sir. Okay, so ganyan yung gagawin natin bilang dyan. So again, the word N1, so yung the word P is, the letter P is 1. So once ko nakita sa word ng probability, sa N2, si, sino ba yung N2 natin? R, no? Si R is 1, isang beses ko lang nakita. Si B, dalawang beses. Si O, isang beses. Si A, isang beses. Si I, dalawang beses. Si L, isang beses. Si T, isang beses. Si Y, isang beses. So ngayon, ito rin yung medyo magandang tip na rin. Kung 1 lang naman yung bilang, huwag mo nasama dun sa ating formula. Okay, kasi ganito lang mangyayari. Ngayon, sinod natin siya. Ang mangyari lang is just 11 factorial all over. Start tayo dito. Sabi, 1 factorial multiplied by 1 factorial multiplied by 1 factorial. Nagkakamali na ako. Multiplied by 2 factorial multiplied by 1 factorial multiplied by 2 factorial multiplied by 1 factorial multiplied by 1 factorial multiplied by 1 factorial. Kumbaga naulit lang eh. 1 factorial is just 1. So this is just the same thing as 11 factorial over 2 factorial times 2 factorial. Okay, so in that case, pwede ka na mag-calcu. So calcu na lang yan. That is simply 11 factorial over 2 factorial times 2 factorial okay, so that is simply 9,979,200. So this is just simply 9,979,200 ways. Okay, so ganun siya karami. So ganyan magagamit yung formula. Again, pag 1 lang naman nag-exist yung letter na yun, pwede yan. Okay, then again, hindi yan lang basta dyan sa word na letter lang ha. So itong formula to, hindi lang basta dyan ha. So pwede rin yan dito, tulad nito. So how many different signals, each consisting of 9 plugs, hung in a line, can be made from a set of 4 white plugs, 3 red plugs, and 2 blue plugs. So again, hindi ko kinuklose yung mindset na dapat dito lang. So dito, in terms of 9 plugs kasi yung gagamitin. So meaning, n yung 9 natin dito. Okay, then n sub 1 natin dito is yung 4 para sa white plug. Okay, n sub 2 natin dito is 3 para sa red plug. Then n sub 3 natin dito is 2 para sa blue plug or blue plugs. Okay, then simply input lang natin sa ating formula. This is 9 factorial over 4 factorial times 3 factorial times 2 factorial. So ilan yan? Calculate nyo na lang sa itaas. So that is 9 factorial over 4 factorial times 3 factorial times 2 factorial. So again, huwag nyo kalimutan yung multiplication sa gitna ng mga factorial. Hindi kasi siya parang literal na mag-multiply. Pinalagay mo 4 factorial, 3 factorial, hindi siya literal mag-multiply. Okay, so that is 1,260 ways or different signal. So this is 1,260 different signals. So pwede naman yun. Kung ano rin inaas, okay lang din naman lagay. Okay, so ganun siya kasimple. So ganun naman yung ating permutations with things that are alike. Okay, then lastly, we have the circular permutation. So, if n objects are arranged in a circle, so pag sabi nga circular permutations, itong may consider nyo, if n objects are arranged in a circle, the number of permutations is n minus 1 factorial. So, sir, bakit po ganun? Kasi nga, imagine mo paikot. So, meaning kasi doon, may isang, sure ako, sa kunyari, 5 tao sa round table. So, sure ako na may isa doon, pag pinaikot ko yun, may isa magre-retain sa place niya. Kumbaga na ba, hindi siya, kumbaga hindi nagbago. Kumbaga, same as count, kunyari, iba man yung permutation, same as count sa iba. Kunyari, arrange mo man sa permutation, mag-same as count. Kaya mababawasan siya almost ng 1 ng isang factorial. Kaya nga n minus 1 factorial siya. Okay, so as long as ito hindi laging sinabi pag table, automatic na sinabi table, hindi focus, hindi mo dapat isipin na ganda sir, round table ba to? Hindi. Pag sinabing table, pwede rin kasi square. Okay, so iba na kasi yung mangyayari kung gawin mo siyang square eh. Okay, so again, pagdating doon, iba na medyo yung magiging arrangement or something. Okay, so as long as makaka-form ng round or bilog, go ka. So for example, si bracelet. So yung mga letter, gagawa ka ng letter sa gamit yung, o yung mga beads, gagawa kang bracelet. So, yun pabilog yun. So, pwede dito yung circular permutation. Okay, so, proceed tayo dito. So, sabi, how many ways can you seat 10 people in a round table with 10 seats? So, drawing ko lang para makita nyo na rin. So, assuming na perfect circle yan. So, ito ay 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, assuming lang kakahiwala yan. Basta round pa rin yan. Nagulat ako, kalapit. So ngayon, how many ways? So wala naman tayong kino-consider na iba pang arrangement. So that is simply 10 minus 1 factorial. So using the formula, this is just, since circular siya, this is just equal sa 10 minus 1 factorial, or just equal sa 9 factorial. So ilan ulit yung 9 factorial? So base kanina, ang 9 factorial is 362,880 ways. So, ito yung ating sagot. So, ganun siya kasimple sa circular permutation. So, lastly, syempre, lagyan natin ng konting twist para imagine nyo. So, sir, pwede po ba dito mangyari is yung dalawa ayaw maghiwalay? Yes, pwede dito mangyari yun. Yung dalawa ayaw maghiwalay. Okay, so before tayo magpunta sa next topic natin. Okay, so number 2, in how many ways 6 individual, sorry, mali yan. Dapat 6 individual yan. Type ni sir yan. So, 6 individual. So, 6 individuals can be seated around the table with 6 chairs if 2 individuals wanted to be seated side by side. Okay, so katulad din kanina, so ayaw nila maghiwalay. Pero dito, obvious naman dito, hindi fix na dulo-dulo yung dalawa. Kasi dito talaga round maghihiwalay lang sila. So, nyari, drawing natin. Nyari, ito si 1, 2, 3, 5, 6. Basta magkatabi yung dalawa. So, syempre ito yung dalawang yun. Gusto lang nila lagi magkatabi. Okay? So, using yung ating same concept dun sa ating kaninang sa example natin na ang ginawa natin is yung since linear, magtabi sila, i-count natin sila as 1. So, i-count natin sila as 1. Pasok pa rin yun. So, i-count natin sila as 1. So, meaning, ang mangyari dito, since i-count natin sila as 1, magiging 5 minus 1 factorial na lang to. So, this is just 5 minus 1 factorial. Then, multiplied by yung arrangement ng dalawa. So, this is just 2 factorial. So, therefore, this is 4 factorial multiplied by 2 factorial. Okay? So, simply, this is 48 ways. Okay? So, ganun naman dito. So, dito kasi magkatabi sila. So, again, count mo lang sila sa isa. So, since circular siya, so, 1, 2, 3, 4, 5, 5 na lang. So, 5 minus 1 factorial times 2 factorial. Kukonsider natin yung arrangement pa nung dalawa. Okay, so that's all for this topic. So, that is all about permutation. So, naturo ko yung mga possible formula, yung possible way, or mga possible tanong. So, marami talagang possible na tanong dito sa permutations. Okay, so, hoping na manood ka pa para sa next video. Kasi next video is all about combination naman. So, again, thank you for watching.